So we finally got to the infamous unit circle that I've been talking about. Uh, what this is if you have a circle with a radius of 1, we can actually predict all of the points on that circle given a particular angle. And you notice this circle has been cut into fourths. You have pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4 would be 3 pi over 2, 7 pi over 4, and 8 pi over 4 is 2 pi. You've also got it cut into sixths, 1 pi over 6, 2, 3, 4, 5, 6 pi over 6, and then 7, 8, 9, 10, 11, 12 pi over 6, and you finally have it cut into thirds. 1 pi over 3, 2 pi over 3, 3 pi over 3, and then 4 pi over 3, 5 pi over 3, 6 pi over 3 is 2 pi. So that's essentially how your unit circle is sliced up at all of the different common angles we've talked about. And as you can see, each point it is listed here as if you had a triangle. So here you can see we have, of course, at the angle 0, we've gone over 1 and up 0. However, at the angle of pi over 2 or 90 degrees, we've gone up 1 and over 0. So those points actually correspond with the trig functions. If you understand that x is equal to cosine of the angle given, and y is equal to the sine of the angle given, and they're in alphabetical order. If you get confused on which one's which, then you can know, if you remember these points around the circle, by knowing that x is cosine theta, y is sine theta, and then you realize tangent theta is sine over cosine, you can essentially find all 6 trig functions by memorizing this unit circle for a plethora of angles. So let's go ahead and look at a couple. First, we have the sine of 7 pi over 6, which would be 1 pi over 6 past 6 pi over 6, which is 1 pi. So we have it here at 7 pi over 6. And notice that the corresponding point there is negative root 3 over 2 and 1/2. Sine corresponds to y. So my answer there, and I should have said negative 1/2. My answer there is negative 1/2. Now we want to find the cosine of pi over 3. So if we look at pi over 3 on our unit circle, this line here, cosine corresponds with x. So the x coordinate at that point on the unit circle is 1/2. So my answer for cosine of pi over 3 would be 1/2. Now we're trying to find the tangent of 4 pi over 3. So 4 pi over 3 would be right here. So the tangent is going to be the sine over the cosine. So we're going to take negative 3 or root 3 over 2 divided by negative 1/2. So negative root 3 over 2 divided by 1/2. Let's flip the fraction, and we get negative root 3 for our tangent of that angle. Finally, let's look at the exact value of the secant of 270. First, let's turn that into radians. So 270 pi over 180, if we divide the top and bottom by 3 and by 10, we essentially get 9 on top times pi over 6, and I guess we can divide that by 3 one more time and get 3 pi over 2. So 270 relates to 3 pi over 2. We're trying to find the secant, so let's figure out the cosine. The cosine of 3 pi over 2. So we have 3 pi over 2 down here. The cosine is x, which is 0. And I'm trying to find the secant. So the secant of 3 pi over 2 is 1 over the cosine of 3 pi over 2, which is 1 over 0. So therefore, this we can't divide by 0, so this is undefined, which you'll have sometimes if 0 is in the denominator. So I hope you were able to see the value of the unit circle and how you can use it to find various trig functions. Now see if you can use the same unit circle to find the tangent of 7 pi over 6.